Hello, everyone. So the looks like the projector doesn't work, so I'm just gonna try talk this. Uh, so we're PamirAI, PAMIR.ai. You can just look it up. So we are a small startup at San Francisco. So we specialize at just bridging AI and hardware, put it together, try to use that to help other people to build hardware. So this talk is mainly about like how we use that to enable one of the village in DEF CON, and how do we power their it's a biohacking village, so we're gonna talk about how is that gonna enable medical related stuff. Yeah, so the company is built by just me and my co-founder. We used to work at Microsoft and Qualcomm, so that's how we know how to handle the AI and hardware part of stuff. So how do we run like AI model today, right? For any model that's larger than like 70 billion parameter, like whatever you use on ChatGPT is like huge models. You can only host it at a GPU cluster, which we probably don't have it at home. So most of the people, they use the model ranging like 13 billion parameter to 30 billion parameter. You can run that on a really good MacBook or like a Mac Studio size of hardware, which is still very expensive. And then you can drop that down to like 0.5 billion parameter to 7 billion parameter. Those kind of stuff you can probably run like on a very good phone, and you can get a decent result out of it, but it's not gonna be as smart as ChatGPT, right? So that kind of leads where our company started. What about embedded system? You know, there's a lot of hardware stuff is built on a single board computer like Raspberry Pi, Arduino, ESP32, those kind of stuff. Like no one's building a local AI for that, right? So but fortunately, in the past half year, there's a lot of progress in the open source community made. There's model called Quinn, QWEN, you can look it up. And there also Llama, they released a 1B model to a 3B model. And a lot of stuff done by Hugging Face as well. It's called a small LLM, SMOL LLM. They released a lot of 3 billion parameter to 4 billion parameter model that's also really good. Also, Google has one particular model called Gemma. That's also performance very well. So thanks to the open source community, we now have a small enough model that we can squeeze into an embedded system. So that's where our company start to mess around prototyping those kind of stuff. So I tried some of the model on a Raspberry Pi, so you don't have to. Around 1 billion parameter, you can get a like okay-ish communication going. Like it's not very smart. It's kind of like talking to a 10 years old. It can tell story back to you. So that's that. But when you get it to like 2 billion parameter, it can start to make like JSON type of request. So it started getting useful. Once the model reaches 3 to 4 billion parameter, it's starting to get very reliably calling like a Python function. So that's where we start to collaborate with Biohacking Village. So we made this badge that's built on a Raspberry Pi 5. If you want to get it, you can check out at the Biohacking Village booth. So essentially, we miniaturized the inference engine into a badge form factor, and we can make it to control real sensor and do simple medical QA. So there's like 4 LED on the badge. You can talk to it, and it will try to rationalize what kind of color you want and make a Python request to turn on those RGB LED. And the funny thing is when you say, I want a red or green or blue color, it was able to very reliably recognize those commands. However, if you say, I want a pink or purple, which require reason ability, the model start to not getting it, right? Because they cannot one-shot it. It's an RGB combination, so they have to think, okay, what's the combination for pink, right? It's probably like 100 for red, then 50 for green. So that's where the small models start to become not so smart. So sometimes they give you wrong color, but we know it's smart enough to control simple sensors. Like if you give it a moisture sensor or just like a simple, I don't know, IR sensor, it can probably help you to use that, right? And I really encourage everyone to check an open source model called MED-Gemma, MED-Gemma. It's an open source model made by Google. They made a lot of interesting research on that model. They use it to do clinical reasoning for medical records and just general medical knowledge answering. We actually put a 4 billion parameter model into this small Raspberry Pi. So it's not like hyper accurate, but yesterday someone came by and asked like how much of a antibiotics medicine I should give to a 2 years old. So he kind of gave back an answer in terms of milligram, and that's kind of in a correct range. So we were surprised. Okay, yeah, he definitely knows more medical stuff than me, but I think that's good enough for like a doomsday device part. Yeah, also Google mentioned they use it to do X-ray, chest X-ray report generation, and it turns out it's pretty decent. So I encourage everyone to check that out. So we know with a small model we can get that far. So what if we put just like ChatGPT or Anthropic, those huge model, to enable them on the device? What's going to happen, right? So imagine we put. I know if everyone here is a technical. Like I use Cursor, those kind of AI IDE to code every day. So imagine we put that into an embedded system. So what's going to happen is you put in plain language, you connect sensor to it, it can generate and load the driver for you. Also, it can probably log the data for you, build a UI for you, and retry on arrow. You don't have to write a single line of code because the whole embedded system is controlled by AI agent essentially, right? So some example we done in the past by just leveraging the Astrotropic model to control a full Linux system. Let's see what it can do, right? So I had this Flipper 0 thing, and I wanted to write a screensaver for it, but I don't know how to do that. So I connect that to the single board computer we made. It's like this size, and there's a Raspberry Pi 5 in there. We give full control of that Raspberry Pi to a very big cloud model, right? So we find out there's a command line driver or like SDK for just writing Flipper 0 customized code, right? So it's just utilizing that to write me a screensaver. Similar thing for Arduino or Raspberry Pi. I plug it in, tell it what's the serial number, like what's the product number on what type of Arduino it is. It will go download. There's actually a Arduino IDE CLI. I didn't know that, but the AI found that thing and just programmed the Arduino with a CLI. So we also did similar thing to a thermal printer. So we bought a thermal printer from Amazon, and those kind of type of thermal printer, they can only print shipping labels. It's only designed for shipping labels. But I want to use a printer to print whatever I want because I already paid for it. I want to print stickers on it, right? So I plug it into the device. They figure out, oh, this is this brand of printer. They do have a driver for Windows and Mac, but they don't have a driver for Linux. So, however, it's a printer, so it's using a universal protocol. So kind of reverse engineer the printer and wrote a whole driver for the printer. Now I can print whatever I want with a printer. So we also sponsored multiple hackathon in San Francisco. Some people brought a Roomba that they don't need anymore, but they want to control the Roomba. So turns out there's also a USB port for that Roomba. So they plug in the Roomba to the device. Of course, the device, the almighty AI found the driver for the Roomba. Now they can use the Xbox controller to control the Roomba. But so all that is telling us, I used to just copy paste code from Arduino IDE to a ChatGPT and ask questions and copy paste it back. But now I can just chat with it and just write a driver, do everything for me now. I think that's kind of the future we're going at, and I think it's relevant at DEF CON because if you have an AI in your pocket, it can just hack stuff for me. But can we eventually do all that locally, right? Right now I'm using 1 trillion parameter on the cloud, but I do want to use it locally eventually. So there's a paper came out. It's called Multi-Step Planning and Reasoning Improves Acting LLM Agent. You can look it up. It's a long title, but if you Google pre-act paper, it probably show up. So essentially, there's a team of researchers. They find out, if you just fine-tune 70 billion model on those kind of thinking, replanning data set, it can eventually be as good as the huge model run by OpenAI. So I think in the next 2 or 3 months, we can get all those stuff running on my MacBook or just a Mac Studio. So soon we'll get there to run everything locally, which I think is very important for things like medical device or anything that involves my biometric data. I don't want to send that to OpenAI, right? Also, if anyone worked for a medical device company, the UI is hella complex. I don't know how to operate that, but if there's a local model that I can just drop the manual or SDK off the machine, it can operate for me. I think that will enable a lot of medical automation industries researchers to utilize them. Yeah, that's pretty much off the talk. If you got any question, you can stop by the Biohacking Village booth and to learn more. Yeah, thank you.